And then one question you might want to ask yourself is, what should my scale be? Like, how far do I need to go? And the answer is, in the x direction, you can see the graph shoots all the way out here to -10 in the negative direction, and all the way out here to +10 in the positive direction. So I am going to need to go from -10 to 10, right? And then as it turns out, in this case, it's the same for y. It goes up to +10 and down to -10 in the y direction as well. So that might be helpful, that might be useful, because before you start, if you know how big your graph is ultimately going to get, then you have a kind of a game plan, as it were. All right, so now starting with where x equals 0 here and y equals 4, that's going to be my starting point. Another thing to keep in mind is that I have to go all the way around this graph until I come back to that point when I'm finished. All right, and I'm also going to cross through that point on my way around once, but not stop there. Okay. All right. So 0, 4. X is 0. Y is 4. X is 0. X finds a minimum value here at about, I think I'll say -2. So I can go ahead and plot that point. If that's -10, then that's probably about -2 right there. Then the next time X finds a maximum or a minimum, it's over here at x equals 4. I'm keeping my dots fairly close together in this direction because I know I've got a lot of, like, there's a max and then there's a min, there's a max and a min. There's a lot of maxes and mins to get in here. So I'm trying to keep my graph fairly tight. X is 0, X is -2, X is 4. Keep following the graph along and you'll get to another X minimum down here that's about -6 or -7. I think I'll call it -7. It's about there, and I'm kind of eyeballing it anyway. That could maybe be -6. Go back up to this X. Can you see that's an X min right there, or an X max, right? A maximum value for X kind of locally. And it's almost 0, but I think I'm going to say -1. The reason I'm hesitating, I was trying to remember where I got to. This other one was -2, so this one's going to be -1. So that's going to be closer to the x-axis there. Right now, I came down like this. I went to 4, x equals -7, x equals -1. So I keep following along and I get to x equals -10. And then x equals -1, -2, sorry. So -2, which is maybe about there. Trying to keep it fairly tight. And now I've gone down to here to -10, come up to, can you see I'm crossing over here and coming to x equals -2, and now I'm going to turn back and cross back over and go to x equals -9. And then x equals, just following the graph along, x equals, that looks like about, it looks like about 1, but I'm going to call it 2, and here's why. Later on, I'm going to come up to here and get to x equals about 1. And I'd like to be able to distinguish between the two. This is a little higher than this is in the x direction. It's a larger x value than this one. So since I'm just eyeballing and I'm just rounding to the nearest integer, I'm going to call this one 2 so that I can call this one 1. I hope that makes some sense. There's also another 2 right here, by the way. So this is actually a little bit tight, but I'm going to call that one 2. And then what I've done is come around here, -9, 2. Now I'm going to go to -4 for x, and then 7. -4 is down about here, and then all the way up to 7. Now, which way was I going? This is the problem with these. -4, 7, I was going this way. So then I get down to about 1. And I'm going to cross over here and go all the way out to 10. Looks like about 10 there. Continuing, I come down to a 2, and this is really close to 2, whereas this other one down here was not quite 2. So this is a slightly higher value. That's not terribly critical, but it's worth keeping in mind. So there's that one there. Which way was I going on? 10 and then 2. So now to keep going this way, I'm going to get up to 9. And then I'm crossing over again. And here's where I'm crossing over. Oh, looks like I'm done, right? I've come back to where x equals 0. Did I miss something? Feels like I've missed something here. So let me see. I came, I know I was doing this. I came up here and around following the graph. I crossed over here. Remember, that's the one I was asking you to watch out for. That's a crossing place that brings us back to this point here, but not on this path, on this other path. So I went this way, I got to 7, 1, 10, 2. There's my 10, there's my 2, 9, and then all the way back down to 0. So I was right. It comes all the way back down to 0 at that point. Okay. So I would argue there is a graph or some representative points on the graph for x of t. And before I connect the dots, I find that I can actually see what looks to me like a smooth curve. And kind of if you follow in between those points, it's kind of the white space is showing you that looks like it's going to be a cosine curve. Does that make sense? Can you see that?
Yeah.
All right, so let's go ahead and connect the dots, remembering that I started here. No pressure. Okay, that's my bumpy graph. That's the one whose equation I would like. That's the one whose equation I'm trying to figure out, right? I'm trying to build that. In order to do that, let's go ahead and find our midpoints, right? This one's not quite on the x-axis. I'll back up to that one for a second, and then I'll carry on. And I've missed this one on purpose. I'm going to come back and remind us about being careful at the ends there. And my pen is actually kind of naturally trying to follow that nice smooth curve that I had in the white space there before I drew the bumpy graph. Now at the ends, I have a high here and what looks like a low, but I think it's important to point out that if I were to carry on and do another cycle of this graph, it would look like this. Let me get a color that will be helpful here. It's going to do the same thing as this graph here did, which is to do that. And on this side, if I were to go back, it would go all the way up to here, right? So if I'm trying to find my midpoints, the midpoint between this low and the previous high is actually way back here somewhere. Maybe not quite that high, it's about there, right? And on this side, the midpoint between this high and the next low is not here where we think it is, but a little lower than that. And that's something that's worth keeping in mind just because it does sort of, it's not too bad with this one, but it can actually quite significantly change the shape of your graph. So it's something to be very careful about. If I now connect these dots, I get something that kind of looks like this. Okay. And if I were to keep going so that I was all the way out here at 2 pi, then that graph would just be that little bit lower. And this graph would be just a little bit higher, right? So because of where you started, Kathy, it looks a little bit like somewhere between a sine and a cosine, right? But it's okay, we can adjust for that. There are actually a couple of different ways you might approach this. If you look at the graph where it starts looking like a sine graph, then you can take that piece of it. Of course, if you do that, you have to take the rest of this as well and go all the way out to here. But notice that you have now a 2 pi wide section of graph. that looks like a sine graph. It's a negative sine graph, but you can use that piece of it instead. It's as though you started here, you know, a little farther along, okay? It's just as though you started in a different place. Does that make sense?
Yeah.
All right, let's see if we can figure out what the equation of the red graph is. The amplitude of the whole thing is 10. Well, what's the amplitude of the red graph here? Just approximately. What's your best guess there? Can you see it okay?
Is it like 6 or?
Okay, 6, 5 or 6. We'll start with 6. What kind of graph is it? Is it a sine or a cosine?
A sine.
It's a sine. And can you see anything else that we need to adjust
It's
for?
a negative sign.
It's a negative, exactly, because it doesn't start here and go up. It starts here and goes down. It's been flipped over the x-axis, okay? And I get one cycle, so it's just -6 the sine of t, okay? And then we need to figure out, what did I do to my sine graph? Well, starting right here, I added a little something, and this is just a ballpark sketch, right? It's very, very inaccurate, but it's just enough to help us figure out what the pattern is. And the pattern is that as I go along, I might start here. I might just kind of start randomly somewhere in the middle. I've had to add a little, subtract a little, add a little, subtract a little, add a little, subtract a little. Another way you can look at these is that you can draw or think of sort of having a second graph here. That this is my new 0. Okay, this is my new t equals 0, because I moved the graph along a little bit, like I shoved it along and started looking at it from that point. At t equals 0, it looks like I've had to add something. At t equals, go a little bit farther along right here, and I've had to add nothing to the red graph to get to the blue graph, because they intersect there. Over here, I've had to add negative something to my red graph to get to my blue graph. And then I've had to add 0, and then I've had to add, and then 0 and subtract, and 0 and add, and so on, all the way along the graph. Okay, and when I do that, I end up with, it's not a very good sketch, I end up with a graph that looks like this, which keeps going. This is the equivalent of saying, what if I took the red graph, grabbed both ends of it and pulled it tight, right? What would I have? What I would have would be, and I think you'll be able to see that down here as well. I'd have a cosine. Can you see that cosine?
Yeah.
It's the same as that cosine right there. I'd have a cosine on top of this red curve. So I'm going to be adding cosine. All right, and I have cosine, and then I have another cosine. And I left that one really fat. I didn't make this one as fat. So I'm just going to check and see how many of these cosines. Now that I've identified that it's cosine that I'm adding, I'm going to check and see how many cosines I have between where I started and the end of the graph. And the answer is 1, 2, 3, 4, 5, 6, 7. So that makes that 7. And finally, what is the amplitude of my cosine graph there in comparison to the red graph? Well, the total amplitude is 10. So this must be 4. And I would argue that is an X equation that will work for this graph. Okay? Is that anything like what you ended up with?
My group, when we were doing it, we just got like confused with the overlays, and yeah.
That's easy to do. These are hard. Which is why I said yesterday, do your best and I'll see how it turns out, and that's how I'll decide how I'm going to grade it. That's when I'll decide how I'm going to grade it. Because we just don't have the capacity. We don't have the means by which to meet and easily go over these, right? We have this session right here And I think that my demonstration here is very much like what I would have done in class, but it's just harder to interact. It's harder to, I can't see you to see if you look confused. I can't tell if you're like trying to raise, those little subtle things that teachers can see, someone like thinking about raising their hand. So you wait, you pause. I can't tell, I don't have that. So we're all just doing our best. But I know that you are in a difficult situation, and which is why I keep saying, don't panic about this. It's people who aren't trying it at all who are going to struggle. Those of you who are putting in the effort, and not everybody's in the room. There are folks out there that are doing an amazing job with these things, and with little or no instruction, or perhaps they've got a friend or a roommate who's had the class before and kind of knows what's going on and is at least getting some help. But people who are making the effort are going to see that their grades will ultimately reflect that. Okay. So let's try typing that in, and it won't give us the whole thing. We won't be able to see the graph because you need both the x of t and the y of t equation to get the graph. But I'll shortcut the process for y a little bit now that we have a feel for what's going on with x and what's going on overall. Okay. Oh, I'm just seeing your chats here. Where did the 4 come from? Okay, and the response there was the amplitude has to be a total of 10, and we figured out that the amplitude of the red graph was 6. So the amplitude of the blue graph has to be 4, because what do I add here to the red graph to get to the original blue graph here? If this is a height of 6, a maximum of 6, and this is a maximum of 10, then this has to be a value of 4. Okay, and there was a thank you and a no problem, and yeah, okay. It looks like we figured that one out. Thank you for helping with that, folks. That's great. Okay, so shall we try the y equation, or do you have any further questions about the x equation before we start on that? Ready to give it a shot?
Yep.
Okay, I'm going to move y down a little bit. And I'm going to extend my axes. Let me see if I can get rid of that blue dot without, no. Okay. So as previously discussed, we know this is going to go to 10 and negative 10, just like the x equation did. And we can go back up here and look at our x equation if we need it. But ultimately what we need is to try to squeeze it all into about the same amount of space. And in fact, originally our graph went to here. So this would be 2 pi. Okay. All right. Okay, so from the same point here, I'm now looking at the y values. Okay, the y value there is 4. Having started in the same place, I need to go in the same direction. And the next time I come to a maximum or a minimum for y, it will be down here. One thing to keep in mind is that with these non-symmetrical ones, you'll often find that you end up with more points, more wiggles, if you will, in the x than you do in the y, or vice versa. Okay, so we may end up with an even more wiggly graph for y than we did for x, or a less wiggly graph. It just depends on, it depends on a lot of things, but it's the fact that it's non-symmetrical tells me that's a very likely possibility. Okay, so here is where y is 4. Sorry, yeah, where y is 4, and then down here y is negative 1. And then I'm going to go up to y equals 1 before I start coming back down again. And I come down to y equals negative 8, all the way down to here. And then up to y equals, that looks like negative 4. Be about there. Down to y equals negative 10. Can you start to see the white space?
Yeah.
Up to, now where did I get to? Let's start over. So I got down to negative 10, and now I'm going to go up to negative looks like -4 again. Is that right? Let me try one more time here. -4, there it is, -10, and then up to -2. That's a big jump. And then I'm going to carry on until I get to y equals -5. All the way up to y equals +5. That's a big jump too. That happens sometimes. And then y equals 2, 10, y equals 4, y equals 8, and y equals 4 again. Go back to where I started. And I didn't quite make my 2 pi mark there, but that's not bad if I do say so myself. All right, so I can kind of see what the white space is telling me here is that it looks like I'm going to have another sine graph, but let's go ahead and connect the dots and find our averages, find our midpoints. Not an exact science. Okay. I go back and find my midpoints. I'll skip the first one, do the others. Sine and cosine graphs should not look that pointy. They should be more bendy like that, but because of the reason we're doing this graph, I'm not going to worry about it. Now at the end here, if I were to carry on, if I were to start a new cycle, my graph would carry on going down until it got to -1, right? So my midpoint here is going to be, oh, I don't know, maybe somewhere about in there. If I were to carry on from here back, my graph would go up until it got to 8, so it would look something like that. So my midpoint here is actually maybe about there. Okay, so it's important to keep that in mind as you're going forward. Now, if I connect my midpoints, I get this graph. Okay, and I'm in the same situation as I was before. I feel like if I could just start here, I'd have something that looked more like a sine graph. But if I start there, I still need to take a full 2 pi window, so I kind of need to go over to here, which is exactly what I did the last time. Just extend the graph a little bit so that it matches, you know, sine starts at 0 and ends at 0. Okay. So what does my red graph look like? This is going to be y of t equals, the red graph to me again looks like a sine graph. Let me give myself a little more space there. I have one cycle of that sine graph. What's its amplitude? The ones we've been doing, the amplitudes kind of match, right? So should we just say 6? Because it's the same as the one before. It's the same as the x. You certainly can. It looks like this is 10, this is, maybe it's 7, but we'll just start with 6 and see what happens, okay? It's also negative again. And then to that sine graph, to that red graph, I'm adding and subtracting, right? If I have 6, I have a total amplitude of 10, then again, I have to add 4. What kind of graph am I adding? Starting at my 0 place here, I'm adding, this time I'm adding a sine. Can you see that? Is that clear that that's a sine graph? Again, I started here because that's where I moved my new starting point to, right here. And so if I look at that first, coming from that same point, coming off the red graph, I have to do that to get the blue graph. Does that make sense?
Yeah.
So I'm adding a sine this time, a sine plus a sine. And that's maybe the first time we've seen that. We've almost always had 2 sines and 2 cosines, or one of each. Okay, we're just going to argue that that's a last one down there, because this really is not an exact science. So how many signs have I added here? 1, 2, 3, 4, 5, only 6. Okay. So that to me looks an awful lot like an equation for y. So let's try that. I've ended up with -6 sine of t again plus 4 sine of 6t instead of, it's 7t here, we only have 6t here. And that's one of the things that makes it asymmetric. Okay, so let's go ahead and try that. And as you can see, both equations are wrong and the graph is not complete, but it is really actually very, very close. It turns out my overall amplitudes are fine, but as you can see, my loops are the wrong size. My loops are generally too big. There are a couple places in there where they're small, too small, but here, this is too tall. This loop is too tall. This loop is too tall. It's the right width. See, within that little, let me make this bigger. Within this little window right here, the inside amplitude, if you will, x goes from -4 to 1 on both the red and the blue graphs. So in the x direction, I think my amplitudes and my periods and everything are okay. It's in the y direction that things are a little screwy. So my amplitude has to stay a total of 10. But remember back on the main graph when I said that was 10, that looked like we tried 6, but I said, well, maybe it's 7. So let's try 7 because it looks a little closer, doesn't it? That looks a little closer to me than being off by 4. It's maybe only off by 3. So let's try making this 7 and 3 instead. They still have to add up to 10. Well, let's just try that. And there you go.